quantitative ability, problems on mixture and alligation. Let us understand the rule of mixture. Mixing of two or more items of different qualities produces a mixture. For example, when two solutions of different qualities are thus mixed, the quality of resulting mixture lies in between the quality of superior and inferior solution. Example 2. When two types of products of different prices are mixed, the price of resulting mixture lie between the price of cheaper and dearer product. Suppose if three different qualities of milk costing rupees 45, rupees 50 and rupees 60 per liter are mixed in the ratio of 2:3:5, then the cost of resulting mixture is found by weighted average like this. So the first milk is 45 rupee and it is taken two parts. So I will multiply 45 with 2. The second quality of milk is costing 50 rupee and it is taken three parts. So I will write 50 into 3. And the third is costing 60 rupee per liter and it is taken five parts. So I will write 60 into 5. To take the average, I will divide it by 2 plus 3 plus 5, which will give me the cost of mixture as rupees 54. Rule of alligation. It is a rule that enables us to know the ratio in which two ingredients at a given price or quality to be mixed in order to get the mixture of desired price or quality. So alligation always gives us the ratio in which two different qualities of items or price of items to be mixed. It is found like this. On the left hand side, suppose if we write the price of dearer item, and on the right hand side we write the price of cheaper item. At the center, suppose we want the required price of the mixture or so called average price, then the ratio can be found like this: dearer minus average here and average minus cheaper on this side. This is the required ratio. Well, let us understand this by taking one example. A petrol pump owner is buying petrol for 100 rupee a liter, but he is adulterating that petrol by mixing kerosene in it, which is costing 40 rupee a liter, because he wants to bring down the price of petrol from 100 rupee a liter to 90 rupee a liter to make profit. Okay. Now suppose if we want to mix these two qualities of fuel, one is dearer, that is 100 rupee a liter, and second is cheaper, which is 40 rupee a liter, to bring down the cost to 90 rupee a liter, in what ratio should we mix petrol and kerosene? And here comes alligation. It is just cross subtraction. 100 minus 90 we will do, that comes out to be 10, and here on the other side we will do 90 minus 40, which is equal to 50. Hence the required ratio in which petrol and kerosene to be mixed is 5:1. Alligation example number 2. Now there are two vessels A and B. Vessel A contains 70% milk and 30% water, and vessel B contains 40% milk and 60% water. This is an empty vessel in which I want to form a resulting mixture containing 50% milk and 50% water. Now the question arises is, in what ratio should I take the solution from vessel A and vessel B? And here comes alligation. Now this particular type of question you need to solve either in terms of concentration of milk or in terms of concentration of water. Suppose if we decide to solve in terms of concentration of milk. Method 1, in terms of milk concentration. So we will write down vessel A, vessel B, and the concentration of milk in both these vessels as like this. As vessel A has 70% milk, I have written here 70. Vessel B has 40% milk, so I have written here 40. Now what concentration you want in the resulting mixture, that should be written in the center here. Okay, so I will write in the center as 50. Now let us do cross subtraction and find the ratio. So 70 minus 50 we will do, and on the other side we will do 50 minus 40. So that comes out to be 10 is to 20 or 1 is to 2. So if I take 1 liter from vessel A, I should take 2 liter from vessel B, so that the 3 liter of mixture that is formed in the third vessel contains exact 50% milk and 50% water. Well, the same question can be also solved by method 2 called water concentration, which will give you the same answer. Let's see. Method 2 in water concentration. So vessel A contains 30% water, so I written here 30. Vessel B contains 60% water, so I written here 60. And water concentration required in mixture is 50%, hence I will write 50% in the center. Now we will do cross subtraction here. 50 minus 30 we will do, and here we will do 60 minus 50. So same ratio you will get, that is 1 is to 2. Let's start with problem number 1. In 20 liters of sugar solution containing 300 gram of sugar per liter, another sugar solution containing 120 gram of sugar per liter is mixed with it. The resulting solution contains 200 gram of sugar per liter. Find the quantity of second sugar solution. Okay, we will solve this question in terms of sugar concentration. Okay, so we will write solution 1, solution 2. In solution 1, there is 300 gram of sugar per liter, so I will write 300 here. And in solution 2, there is 120 gram of sugar per liter, so I will write 120. The resulting solution should contain 200 gram of sugar per liter, so that 200 should be written in the center here. Now let us apply alligation. Let us do the cross subtraction here. So 300 minus 200 will give you 100, and 200 minus 120 will give you 80. So this is equal to 4 is to 5. So solution 1 and solution 2 should be mixed in the ratio of 4 is to 5. Now it is said that solution 1 is 20 liters, and the question is to find the quantity of second sugar solution. So if 4 parts correspond to 20 liters here, 5 parts will correspond to how many liters? That is the question. 4 parts correspond to 20 liter, it means 1 part will correspond to 5 liter. So 5 part will correspond to 25 liters. This is the answer. Option C. Problem number 2. A vessel contains 20 liters of a mixture of milk and water containing 60% milk. If 5 liters of pure milk is added to it, then find the percentage of milk in the new mixture. First of all, you need to decide whether you want to solve this question in terms of concentration of milk or concentration of water. Suppose if we decide to solve in terms of concentration of milk, so the solution is 60% concentrated as it has 60% milk. So I will write here 60, and to that we are adding pure milk. So it is 100% milk only. Well, we need to find a concentration of mixture here. So that is unknown to us. Let us assume it as X. Now this X is greater than 60, but this X is less than 100. So when we do cross subtraction, here we will do X minus 60, and on the other side we will do 100 minus X. Well, this solution is already 20 liters given, and pure milk added to it is 5 liters. So this particular ratio is in the ratio of 20 is to 5. Now let us solve this. So 100 minus X divided by X minus 60 will be equal to 20 divided by 5. Simplifying this, you will get X as 68. So this is the concentration of milk in the resulting mixture, 68%. Problem number 3. Two varieties of rice are mixed together in the ratio of 2:3. The cost price of each kg of second variety is rupees 5 more than the cost price of each kg of first variety of rice. If the cost price of mixture is rupees 25, then find the cost price of first variety of rice. Well, there are two varieties. I will written like this, first and second. If I assume the cost price of first variety as X, obviously the cost price of second variety will be X plus 5 because it is 5 rupees more than the cost price of each kg of first variety of rice. Well, the cost price of mixture is given to you as 25, so that 25 can be written in the center. It's obvious that this 25 will be more than X, but this 25 will be less than X plus 5. So when we are doing cross subtraction, we will do 25 minus X on this side, and on the other side we will do X plus 5 minus 25. Well, we know the ratio that is already given in the problem, that is 2:3 of first and second variety. So this is equal to 2:3. Now let us solve this like this. X plus 5 minus 25 divided by 25 minus X is equal to 2/3. Solving this, we will be able to determine the value of X, which comes out to be 22 rupees. So this is the cost price of first variety of rice. Problem number 4. How many liters of mixture having acid and water in the proportion of 3:2 should be added to 60 liters of 75% acid solution such that the resultant mixture having 2/3 of acid is obtained? Let us say we are solving this question in terms of acid concentration. So acid in the first solution is 3/5 because in the first solution acid and water are in the ratio of 3:2. If there are 3 parts of acid and 2 parts of water, total are 5 parts, out of which acid is 3 parts. Hence the concentration of acid in first solution is 3/5. Acid in second solution is 3/4 because it is 75% acid solution. It means out of 100 parts, 75% or 75 parts are of acid. So 75 out of 100 is 3 out of 4. So this is the acid concentration in solution 2. Acid concentration in final mixture is already given, that is 2/3. So here we know the concentrations in fraction. So solution 1 acid concentration 3/5, solution 2 acid concentration 3/4, and resulting concentration is 2/3, which is written in the center. Now let us do cross subtraction here. Well, I will do 2/3 minus 3/5, which is equal to 1/15, and 3/4 minus 2/3, that is equal to 1/12. So this particular ratio we are getting in terms of fraction. We can bring it to integer by multiplying it with LCM of 12 and 15, which is 60. So if we multiply it by 60, the ratio comes out to be 5:4. Now here it is mentioned that the second solution is 60 liters, right? And you need to find out the quantity of first solution. So 4 parts correspond to 60 liter. It means 1 part will correspond to 15 liters. Now the question is 5 parts will correspond to how many liters? That should be equal to 75 liters. Option B. Problem number 5. There are 2 glasses having mixture of wine and water. In glass 1, the ratio of wine and water is 1:2, and in glass 2, the ratio of wine and water is 4:1. Find the amount of mixture that should be taken from glass 1 in order to make 280 ml of mixture containing equal amount of wine and water. Well, you can pause this video and try this question on the paper. And once you have solved it, you can again play the video to look for the solution. Okay. Let us say if we decide to solve this question in terms of wine concentration. So what is the concentration of wine in glass 1? the ratio of wine and water is 1:2. It means if there are 3 parts, out of which wine is 1 part and water is 2 parts. So wine is 1 part out of 3 parts. So concentration of wine in glass 1 is 1 out of 3. Similarly, in glass 2, the ratio of wine and water is 4:1. It means if there are 5 parts, out of which wine is 4 parts. So concentration of wine in glass 2 is 4 out of 5. And in the resulting mixture, we want equal amount of wine and water. So in the mixture, the concentration of wine is 1 out of 2. Now we can write it like this. Glass 1, wine concentration 1/3. Glass 2, wine concentration 4/5. And in mixture, wine concentration as 1/2, like this. Now we will do cross subtraction here. 4/5 minus 1/2 is 3/10. And 1/2 minus 1/3 is 1/6. Now this ratio we obtained in fraction. We can bring it in integer by multiplying both this fraction with the LCM of 10 and 6, which is 30. So if we multiply this with 30, we get the ratio as 9:5. So if 9 parts I am taking from glass 1, I should take 5 parts from glass 2. The total mixture that we are forming is 280 ml, and the question is how much you will take from glass 1. So I will say 9x plus 5x is equal to 280 ml. Solving this, 14x equal to 280 ml and x will equal to 20 ml. Now the question is how much you will take from glass 1. You will take 9x, in which x is 20. So 9 into 20, the answer is equal to option A, 180 ml. Problem number 6. A vessel has 60 liters of solution of alcohol and water having 80% alcohol. How many liters of solution must be withdrawn from the vessel and replaced with water so that the vessel should have 60% alcohol solution? Now let us say if we decide to solve this problem in terms of alcohol concentration, we can write like this. The solution has 80% alcohol and it is replaced, some part of it is replaced by pure water जिसमें alcohol 0 रहेगा. Well, we want to bring down the concentration from 80% to 60%. So that 60 should be written in the center. Now let us apply alligation here. 80 minus 60 is 20 and 60 minus 0 is 60. So this is in the ratio of 3:1. So there are total 4 parts and that's 4 parts correspond to 60 liters of solution present in this vessel. Now we want to replace it because it is asked how many liters of the solution must be withdrawn from the vessel and replaced with water. How much we need to replace? 1 part we need to replace with water. So 4 parts correspond to 60 liter, hence 1 part will correspond to 15 liter. 1 part, that is 15 liters of solution, to be removed and replaced with water to bring down the concentration to 60%. Option B is the right answer. Problem number 7. A drum is completely filled by mixture of alcohol and water. By replacing 12 liters of solution from the drum by 12 liters of water, the concentration of alcohol drops from 18% to 15%. Then find the capacity of the drum. Well, suppose if we decide to solve this question in terms of concentration of alcohol, the concentration of alcohol in the solution is 18% and we are adding it pure water जिसमें alcohol का concentration 0 होता है. Well, we want to bring this concentration from 18% to 15%. So that 15 should be written in the center here. Now let us apply alligation. Let us do cross subtraction. 18 minus 15 is 3 and 15 minus 0 is 15. So 15:3 or 5:1. It means the total parts in the drum are 5 plus 1, that is 6. जिसमें से अपन कितना replacement कर रहे हैं? 1 part, because water we are adding 1 part by taking out 1 part of solution. So replacement done is 1 part, and which is equal to 12 liter as mentioned in the question here. So if 1 part correspond to 12 liter, we are supposed to calculate what is the capacity of the drum. Capacity of the drum is 6 parts, that is 6 into 12, which is equal to 72 liters. Rule of dilution. Suppose if there is P liters of pure liquid initially and it is replaced by Q liter of another liquid every time, then at the end of n such operations, the percentage concentration of liquid in the solution is given by this expression. P minus Q by P to the power of n into 100 is the remaining concentration of the solution. Let's solve an example on problem of dilution. From a vessel containing 300 liters of pure milk, 60 liters is taken out and was diluted with 60 liters of water. Again, 60 liters of diluted milk is taken out and is replaced with water. How much is the concentration of milk after these two operations? ऐसा 2 बार किया गया है कि 60 लीटर्स निकाला और उसको पानी से रिप्लेस कर दिया, तो 300 लीटर प्योर मिल्क में अब कितना कॉन्सेंट्रेशन बचा है? So what is given here? P is equal to 300 liters, that is the quantity of pure liquid. Q is what? The liquid that is taken out and replaced with water, and N is equal to 2. This operation is done for 2 times. So we can apply the expression and find out the concentration of resulting mixture after 2 such operations. So P minus Q by P to the power of N into 100 we will do. So P is 300, Q is 60 and N is 2 we will put here. That comes out to be 64%. So ऐसा 2 बार करने के बाद the concentration left out in the milk is 64%. Hope you understood the concepts of mixture and alligation. Please try additional such questions from any of the aptitude book. Thank you very much.